both sides because the distance is 50. I'll take like this. Okay. Now this dimension I have already mentioned that the L, you have 100, 75, 10 means the length is 100. From here to here is 100. 75 is the width, okay, and 10 is the thickness. So first I will take the 100 as my length, 100 L from here. Okay, that's my 100. Then 75 will be my width. Even if you check here from here to here, already it will be 75 already. So no need to take 75. It's already 75 because in the middle we have taken 50, and the thickness is 10. So I will offset 10 from here on the right and here. Similarly, this one is on the left. Sorry, so this is actually a midpoint. I'll just remove it. So it will be like this. So I'm just going to connect this. This is construction, just simply construction using the dimensions. So I just going to trim the lines. Okay, and also I'm going to trim like this. So it will be the L. Okay. Also you can remove this one. See this, something like this. So you have L's on both. So you got L. So this is 100. If you see the dimension, if you want to check the dimension from here to here, it must be 100. Okay, and if you see this distance will be 50 in between. Okay, and this is 75 from here to here, and the thickness will be from here to here is 10. Okay. Now I'm going to draw the bush here in the middle. This is the bush. That is the distance given here. If you see from here to here, it is 65 to get the center, and from center we can take this 32 up and down in order to get the bush. So I'll offset 65 from here. This is my say center line, which I'm going to fix, where I'm going to fix the stud. So this is my center line. Then I'm going to use 32. That is a dimension for the bush. So this will be my bush. Use color. Okay. Then I can trim these lines. You can see the figure and draw. That is, you can just trim the lines so you can show that this is the bush. So this is actually a center line. I'll use some color for that. Okay, this is the center line for the stud. Now we have to do fillet, because if you see the fillet, there is a fillet radius R10. R10 is the radius. To do the fillet, you know how to do the fillet. We already did it in the Mcet201 fillet. Go for fillet. R. You have to type R always. Enter. Then the distance. Sorry, the radius is 10. So you can do fillet. Repeat, and for all 3 edges for the L plates. Okay. Now we have done the fillets. Now we are going to take the center line for the cap screw as well. You can see the same distance. 32 is given on both sides, so we'll take 32 as well. Offset, you can offset 32 from here. 32 is also 32. Okay. This will be my center line for the cap screw where I'm going to use it. So I'm going to change it to a center line. Okay. Now this is actually will be a blind hole. It's not a through hole. Right. Okay. Now first we'll start with the stud. Okay. I'll show you the stud first. M16 stud. Now, as I told you before, that whenever we start any drawing, the the size will be given, that is like M10, M20, M14, whatever. It means the capital D, that is major diameter, will be given. So M16 is a size for stud, and M14 is a size for stud. Sorry, for size for cap screw. We have two different sizes here. One is for stud M16, and 14 is for cap screw. So there is capital D is 16 for stud, and capital D is 14 for cap screw. So if, let us start with the cap screw. So you need to calculate the dimensions like the formulas. Last week we have used some formulas. If you go back to exercise 2.3, the width 1.5D to draw the hexagon, 2.2 by 3D, 7 by 8D, small d, that is 0.85D. The formulas will be constant. Okay. Now remember one thing. Whenever we start any thread fastener, whether it is a cap screw or a stud or a bolt nut, we always start with the hexagon. We always start with the hexagon. This is actually the width, that is 1.5D. Remember this one. Whenever you want to draw something like a bolt nut or a stud or a cap screw, you must start with the hexagon. Okay, and the rule for the hexagon is same. If you go back to the 2.3 exercise, you see the rule 1.5D. If you are drawing the bolt, the rule will be same, and nut, if you are using, the rule will be 7 by 8D. So you must remember these rules. Using these rules only, you are going to calculate and draw the dimensions, because only D, the capital D, will be given. The other things you need to remember and calculate accordingly. Now I'm going to draw a stud here. So I'm going to draw the hexagon first, then I will be able to project the lines to draw the nut. Now here I'm going to use nuts because this is a stud, so I can only use nut on both sides, one on the left and one on the right, one on the right. Like it will be something similar to this one. If you go back to this exercise 2.3, yeah, you see this one. This is threaded on one side. You have a nut. Similar, it will be similar to this, but it will be a mirror image. Let me just. So I'll start with the hexagon first. Okay, let me just take one more line here somewhere. Okay, this is also my center line. I'm going to draw the hexagon. Same rule. Number of sides 6. Okay, I'll start center here. Now you know this inscribe and circumscribe. We usually go for C, that is circumscribe. I have already shown you last week. Okay. Now you need to calculate first. It's asking me the radius. So use a calculator. Now what is the rule? The same rule, 1.5 D. The D is here 16. Remember, D is capital D is 16 for the stud. So wherever you are using D, the capital D, it will be 16. So multiply 16, it will be 24. So 24 is my width, but here is asking me to specify the radius. So I told you that whenever you are going to use a radius, you must give half of the width. Don't give 24. 24 is a width, so you must give half of 24, that is 12. Okay. If you have any doubt, just you have an option to check the dimension. From here to here, it must be 24. This is according to the rule 1.5D. 1.5 multiply 16, that is 24. Okay. So this is not the first time I'm drawing. This is we did it in the exercise 2.3. After that, you can draw the same circle using the same radius, 12. You can use the same radius, 12 to draw. But now, one thing is a change here. Now, I'm not going to draw like this because I'm not going to draw the stud vertically, because if you see the position of the stud, it is horizontal. So what we need to do, we need to rotate this, because you are fixing horizontally. You're not going fixing this, because when you draw this hexagon, usually we project the lines like this, just like in exercise 2.3, we project it in order to draw the bolt and nut. But we are not going to draw vertically, right? We are going to draw horizontally. So you must rotate this hexagon in order to project the lines horizontally. So I'm going to rotate this one. Go for rotate from center. Just type 90. So it will be rotated. So when you check this dimension, this will be 24. That is width of the hexagon. Now I will be able to project the lines. Simply I'll project the lines onto this body because I'm going to project the 4 lines. Same. Okay. Now I can fix the nut here. Okay. Now before I fix the nut, as per the question, they asked us to fix the washer. I'll fix the washer and then I'll fix the nut. Now remember the washer dimension I will give you. Just make a note along with the washer dimensions. The total distance, or you can say the height, is 2d plus 4, and the thickness will be 0.15d. Means, for example, if you have a washer like this, okay, if you see the side view of the washer, it will be like this, something like this. Okay, now let us say this is a center line. Okay, now here the dimension means from here to here. This is 2d plus 4, the height. Any from here, total distance or total length of the washer will be 2d plus 4. 2d plus 4. D, you know, that is the given D, that is major diameter. And thickness, this is the thickness actually, this one. The thickness will be 0.15d. So you have to make this note as well, that the dimension for the washer will be 2d plus 4 will be the height, and 0.15d will be the thickness of the washer. So I can fix the nut here, but before the nut, I need to fix the washer to the L angle, then I will fix the nut. So I will take the dimension for the washer first, then I will be able to fix a nut. So what is the thickness? Is 0.15d. So I'll take the thickness first, 0.15 multiply. The D is 16, okay, 2.4. So I can offset 2.4 from here. So I'll got the thickness, and I need a length as well. So what is the length formula? That is 2d plus 4. 2 multiply, that is d 16 plus 4, that is 36. 36 means I can offset the 18 from the center. So this is will be simply trim these lines. Okay. Right. Now you can clean this area. Okay. Now you got the washer. So I have drawn using the same dimension. If you see the length, this is 2d plus 4, that is 36. And if you see the thickness, this is 0.15d as per the formula. Now above this washer, I am going to fix the nut. Now what is the formula for nut? As per the previous exercise, you see the thickness of the washer, 7 by 8d. If you go to the exercise, you see here, this thickness of the washer, 7 by 8D. So sorry, the nut, the thickness of the nut is 7 by 8D. So we are going to use the same thing. Okay. So 7 by 8D, use the same formula, 7 by 8 multiply the D is 16. Okay. 14 is my thickness of the nut. So I will offset 1, 4, 14 from here outside the, because above the washer. Okay, not from here. Already you have the washer here, so you must offset from here. So you have this thickness you got for the nut. Now always whenever you say nut, it will be something like this. Always remember, whenever you say nut, this one, it will be something. So because when you fix a nut, there will be a nut end. Always there will be a nut end. So it will be similar to that. I'll just show you example. Yeah, something like this. It will be similar to this one like this. So whenever you fix a nut, there is a nut end to this. Then only it will be the representation of the nut. So now the next thing is to draw the arcs. As you know that we need, whenever you draw a bolt or a nut or a cap screw, you must have the arcs. So we are using the same method like 2.3. I have shown you how you're going to use it. So from the end of the circle, not from the end of the hexagon, from the end of the circle, we are going to project a line. Okay, same wherever it is touching the head, we are going to take a 30 degrees angle. Means this angle, this should be 30 degrees. So it should be how much? It should be 60. If I say 60, this will be 30. The same thing. If you go back to the previous exercise, see, I'm using the same method. It should be 30 degrees. Okay. Later on, you can mirror it. On the other hand, then you can connect this second line. Okay. And then you're going to use a 3-point arc. Same method. It's not a new method I'm doing. We have did this in exercise 2.3. Similarly, we are going to use on the left and right the same arcs. Use 3-point arc from here. Take the midpoint. Also here. Okay. After that, you can just simply remove this line and then trim the edges. Okay. Now you got the arcs, but now this nut is not complete without the end. So it must have an end like this. As I told you that we are usually offset 5 to draw this nut end. But in order to draw this, you must have the capital D and as well as the small d. So now we are going to take the capital D and small d with the angles. The same method. So let me just take offset 5 from the nut end. Okay. Now I'll take capital D, small d from the center. The D is 16. Small d is, you have the formula, that is 0.85 D. So D is 16, so you can offset 8 up and down. So this will be capital D, that is the major diameter. Okay. Then I will take the small d as well. What is the formula for small d? 0.85 multiply D 16, that is 13.6. 13.6 means I can offset 6.8 from the center. Okay. Now I have this capital D and small d. And as I told you before that whenever you have this capital D, the big D and small d, it should not come inside the bolt, it should not come inside the nut. So we are going to clean up. So you just need to trim it. Like you see, it's coming inside the washer, it's coming inside the bolt. So I'll just trim the lines. I'll remove this. Similarly here in the washer, trim this, capital D, small d. Okay, should be like this. Then here also I will trim it. This is that. Now, also we'll assume the thread length. As I told you, what is the thread length for? And from here to here, we say thread length, which is threaded. So similarly, we will be assuming some line here, somewhere close to the nut. Maybe I'll use it somewhere here. Okay. This will be my thread length. So again, I will trim it. Okay. Now, the final thing is the angles. As I told you, one side will be 45 degrees, the other side will be thread run out, that is thread 30 degrees with the center line. Like here, see one side 45 degrees and other side thread run out using capital D and small d. So we are going to draw the angles. You see this one using small d. Take 45 degrees angle, joining the capital D and small d. Same thing, I can project it. You can mirror the same thing on the other side and trim it. Like this. So you got the 45 degrees chamfer, the same thing. And the other side will do thread run out. Thread run out means this angle with the center line. Always it should be linked with the center line. It is linked reference to the center line. It should be 30 degrees. So I directly will take 30. You can see if you want to see the dimension. This line with the center line, it must be 30 degrees. So I can just mirror it on the other side. So your nut is ready with the washer. The only thing here, there is one problem here. Whenever, because this is a sectional view, we are going to show in a section view. This line is actually the line joining this part and this part. So this line, which is the joining line for these two parts, the partition line, should not come inside the hole. Means in sectional view, the hole should be clean. Only you must have a capital D and small d. You should not have any other lines. So this is coming inside. So it is really important to trim this line. See, I'm going to trim this because it is coming inside the hole. So always remember, it should be like this. The other side will be same because as I told you, stud is threaded on both sides. You have threads on both sides. So you're going to use another nut on the right side. So no need to draw because you're going to draw the same washer and nut on the other side, on the right side. So what I will do is simply I will mirror it because I have the same thing on the other side. So I'll simply remove all these lines. You can save your time. Simply you can save your time. So what you do, simply select everything, the capital D, small d, select the nut, select the washer, okay, copy, make sure that every lines, every angle, the arcs is selected, and you can simply mirror it on the other side. Okay, because it's an opposite side, so you need to mirror, you cannot copy. See, that's it. And this line which is coming inside the hole, I need to trim this because this line, okay. See, you got the stud because stud is threaded on both sides. It will be a mirror image, it will be same on both sides. So because it's a through hole, so you will have two nuts, one on the left and one on the right. I hope you understood this construction of a stud, washer, joining this, you know, three parts. Okay. After after that we'll do the hatch, but we'll not do hatching now. We'll finish the cap screw and then at the end we do the hatch. Okay. Now let us come to the cap screw. Now here we are going to draw the cap screw. Don't worry, the construction is available in the YouTube links. So even if you are going to practice, you are going to draw it, that links will be helpful, inshallah. Now I'm going to draw the cap screw here. Same, I will start with the hexagon here. But this, if you see this, the cap screw is vertical, not horizontal. So we are going to draw the hexagon, and then we are going to draw the construction of the cap screw in a blind hole. Okay. But here there is slightly there is a difference. If you see a cap screw, I'll just show you the construction of a cap screw. No, I'll just take this. Okay. The construction of the cap screw. Anyhow, we are going to draw with the hexagon. We are going to start with the hexagon as usual, using the same formula. Okay, 1.5D, same formula. Okay, and we are going to project it, and then we are going to draw. Now, this thickness, the head of the cap screw, will be similar to bolt, because I told you cap screw is also called as bolt, right? So we are going to use the same dimension, the same thickness for the bolt. That is, what is the thickness of the bolt? 2 by 3D, the bolt thickness. I hope you remember from the last week. We are going to use the same method, 2 divided by 3, multiply the given D. We are going to use it for the same as cap screw, because cap screw is similar to bolt. But nut is 7 by 8D. Don't get confused between bolt and nut. Nut is 7 by 8D. That is a different thing. Now, and from the figure, this is 10, and this is 60 from here to here, which is the base actually. From the figure, I'm just showing you an example. Now, the depth is given in the figure, that is 45. So we are going to take depth from here to here, which is given in the question. They say 45 is the depth, 45. Okay. Now here, we have two more angles added here. One angle is the drill angle. If you see the V, something like this is called drill angle, the V. Then we have a tapping angle, and then this is actually the 45 degrees for the cap screw itself, and this is the thread run out. So only these two angles are new. Already you know this is a thread angle, thread run out, that is 30 degrees with the central line. This is 45 degrees angle. You already know that whenever you have end of the threads, you have 45 degrees. Only this angle, this is tapping angle, is added here. So let me just go back. Just zooming. Now, as I was telling, that only this this is the angle, that is 45 degrees common, 45 degrees. Okay. We have one more angle, this one, which we call as tapping, or you can say this is for the threads actually. It's similar to thread run out. Thread run out. Means this angle with the center line will be 30 degrees, thread run out. The last one is the drill angle. This is drill angle. When you take the depth and when you make the drill, so this will be 120 degrees included angle, the angle included in the V will be 120 degrees. Means something like this. We have like this. Say this is the V. So this angle should be 120 degrees included angle. So only two angles are added here. This is 30 degrees with the center line, thread run out, that is tapping angle, and the drill angle. The remaining, this is 45 degrees for the cap screw, and this is thread run out for the cap screw. Okay. Now I'm going to start with the hexagon first. I'll go for the hexagon. Number of sides 6. Same C 1.5D. D is 14 here. Remember, not 16. Okay. M14 is for cap screw. So I'll use the same formula 1.5 D, that is 14. Okay. 21 is my width of the hexagon. So how much should be the radius? Should be half, right? Half means how much? 10.5. So if you want, please check the dimension. Whenever you draw the hexagon, please check the dimension. As per the rule 1.5D, it must be correct. Otherwise, if your hexagon is wrong, then the entire projections will be wrong. So make sure you have the hexagon size, the hexagon dimension correct. So I will use the same radius, 10.1. Same method, we are going to project here. There is no need of washer, it is because it is not mentioned, so I'm not going to use washer. Only if it is mentioned, you use it, otherwise no need. So I'm going to drop the lines in order to draw the cap screw head. Okay, the cap screw head, that is similar to bolt. I'm going to use the same thickness, that is 2 by 3D. Okay, remember the thickness of the cap screw, the thickness of the bolt is same. It is also called as bolt. Cap screw is also called as similar to bolt. Only thing, we are using cap screw in a blind hole where there is no space for nut, where there is no through hole. Okay, it's a blind threaded hole. So use it, the same rule, that is 2 by 3 D, that is 14. Okay, 1/4 is the size, so 9.33. So you can offset 9.33 from here. So you got the head of the cap screw, that is 2 by 3. Then you are going to draw the arcs, the same method what we did for bolt and nut, the same thing. And then you have to take the angle, that is 30 degrees, like this. Okay, then mirror it. Then you take another line. Okay. Then use arcs, 3-point arc, in order to draw the arcs for the cap screw. Okay. Then you delete this line and trim the edges. Okay, so you got the bolt. Okay, that is cap screw, head of the cap screw. Now we are going to draw the other side, this capital D, small d, and the angles. Now, as per the question, they have mentioned, you see the question, they have given 45 as a depth. So this 45 will be from this base only, because where you are going to do the drill you are going to do in the base. The base has more thickness. That's the reason we are going to fix the cap screw into the base. You are going to fix the L to the base. So L already it is a through hole, but this 45 mm in a blind hole, so means this from here to here it should be 45. Means out of 60 it will be 45. So I'm going to take 45, that is the depth for making the hole from here, not from the top, because already from here to here it is already given 10. So we are going to use depth from here inside the base. Okay, you know the base. So you take 45 from here, okay, like this. So this is 45 from here to here. So that is the depth. So if you want, I will show you from here to here. I have taken depth from here, not from the top, from here, because it should be inside the base. Okay. Now I'm going to draw the capital D and small d, and then the angles. I'll show you how you're going to use it. How you're going to draw the drill angle, then tapping angle. Okay. First, I will take the capital D and then small d. Capital D, you know 14, so you can offset 7 on both sides from the center. This is the capital D. Okay. Similarly, small d, I will take it. You know the formula for small d, 0.85 multiply 14. Okay. 11.9 is my small d. So I can offset half of it. 5.95 is the half. So this is my small d. All right. Now I got the capital D and small d. Now here I will just trim this because this is the depth. I got it from here. Okay. Now, as I told you here, we have three angles. One is 45 degrees, one is thread run out, and then drill angle. If you see this, uh, as I told you, this is three angles. 1, 2, and 3. So there is no specific distance between them. We will usually assume 5, 5 like this. So one side we can do 45 degrees. This is thread run out, and this is the drill angle. That is 120 degrees like this. So you'll see the construction here. So I'll just offset 5 and then 5. So why I'm taking, because here I can do the drill angle, that is the V. Here I can take the tapping, that is thread run out for the threads, and this is for the 45 degrees for the cap screw. So if you see this, it will be like this. We'll remove this one because the drill angle will be from small d. First I will draw the drill angle, that is 120 degrees between the V, that is included angle. So I'll take something like this. You take 30. You can mirror it and see the angle. See, this angle should be 120 degrees. Okay, what I did is I have taken 60 on both sides. I just took 60 on both sides, so it will be 120 like this. Okay, so just trim it. Remember, the drill will be from small d. Okay, then another angle, that is for the tapping. The tapping will be similar to thread run out. Thread run out means this line with this center line should be 30 degrees. So how much I have to take? I have to take this 60, so it will be 30 here. So take 60 angular. You can see from this angle to the center line, it must be 30 degrees. The same thing I'm going to uh, mirror it on the other side. Okay. Now this is the two angles which are new. The other one you know already, that is 45 degrees. Chamfer between capital D and small d. 45. Now you got the 3 angles. Then moving on to the top side here, we need a thread run out for the cap screw now. Here we need one thread. Usually we assume the dimension somewhere here. The thread length, you can assume it. As I told you, we'll just assume a thread length. And remember this line which is joining the two parts, it should not come inside the hole. So we will trim this line, the partition line. Okay. Then I will delete all this capital D, small d, which is coming inside the board. You must remove all these lines. Okay. Now I'll draw the thread run out again. The same thing, 30 degrees with the center line. This I will mirror it. Okay. We got the thread run out here for the cap screw, and we have angles down here. Now this is done. Now we need the same thing on the other side. So you just copy it because no need to draw. You can save your time. Okay. So simply what I'll do is I'll just take the same center line. I'll copy everything. Cap screw. Make sure everything is selected. Angles, everything. And then you can go for copy from this point to the same center here on the right side. Okay, you got two cap screws. Now here you just trim this line which is coming, this partition line. Remember this one, whenever you are showing hatching, you must remove this one. Okay. Now your figure is complete. The final thing is, the last thing is the hatch, that is sectioning. This is really important. Okay. Now I'm going to show you how you're going to do the sectioning. Remember, whenever you have a sectioning, like if you have 2 parts and 3 parts, you must change the angle of hatch. Like for example, here in the, if you see this drawing, if you see the hatch for this part and this part is completely different. That is actually the identification that this is another part, this is another part, like part A and part B. You see the angle of hatch is completely opposite. So you must remember, whenever you have an assembly of 2 parts or assembly of 3 parts, when you are doing sectioning, you must have opposite line of hatch. I'll show you. That is really important. That is the meaning that this is different part. For example, I'm going to use hatch. Okay. Always use this hatch, whether it is 131. Okay. Now I'm going to use hatch here. See? It is quite big. So maybe I'll use scale. I'll reduce to scale 0.7. Okay. Now you see I did the hatch for this part. Now I need to do hatch for the bush as well here. This is part. There is a bush here. So you must have opposite line. Then only you will be able to identify that this is a different and this is different. So go for hatch. And when you do this hatch, it must be opposite of this. So I will do it first and select this. Go for angle. There is an angle. I'll just change to some other angle, 90 degrees. So you see the line is changed. You see, it must be opposite to each other whenever you have 2 parts. That's the meaning, the how you identify between 2 parts. This is part A and part B, like that. Similarly, we need to hatch here for the base. Now you must have opposite hatch with this respect to this. So I will go for hatch, but you must change the angle Also, I'll reduce this to 0.5. Just want to show you a very important point here. Now, always when you do the hatch for a blind threaded hole, like in a cap screw, see this area is for threaded. As I told you, this area, wherever you see this one, you must hatch here as well. After hatching this, you must hatch the blind threaded hole because this is the representation. So you go for hatch. Okay, you select this area. The area is small, but you have to do hatch. I'll go for hatch. Use the same angle. 0.5. This area might be very small, but you must do it. I'll just, you can see this. See the lines are coming inside this area. This is just a small area, but this is area for the threaded blind threaded hole. Similarly, we'll do hash here. The area where you see this area, left and right. Go for hatch. See this one and this one. So don't forget to hatch the blind threaded area between capital India and small d. Between this angle and this angle, it will be like this. So that's it. That is the construction of the cap screw and stud with the assembly. Okay, with the assembly. Now the question can be, here in place of stud, I can even fix bolt and nut as well, like bolt and nut we have seen last week. So I can use here. One side I can fix bolt, the other side I can fix nut. But as per the question, it is stud here. Okay, so you can go through those videos. Okay, and you can complete. So the end figure will be like this with the hatch and all the representation for these washer, the nut, and the capsule. Are you following or not? Let me just show you one more thing. Okay. Okay. Now this exercise 3.2 you can submit. Uh, that is next week before that is on Monday, 5th October. So you can see that exercise. So please go through the YouTube links that will help you to draw the assembly drawing for cap screw and stud. I hope you understood. Okay, any doubts, guys?
No, it's clear.
Okay. Just let me take the attendance, please. Then I will be. And please remember when you draw the exercise,